7.5 deals with exponential and logarithmic equations. Exponential and logarithmic equations. To solve an exponential equation, there's two different ways that we can solve an exponential equation, and we've already went through one of the ways pretty intensively, and that is getting the same base on both sides. So case one is to try to write both sides of the equation as powers of the same base. So this goes back to, whenever we had 3x equals 9, that one was pretty easy, right? Because we could get the same base on both sides and then just bring those powers down. So what is 9? 3 squared. Okay, since I have the same base on both sides, I can just bring the exponents down as x equals 2. And then I keep mentioning, or I mentioned whenever we first started logarithmic functions. Amy, did you start the video? Okay. Whenever we first started logarithmic functions, if you guys recall, I said well, the reason that we need these is for those instances where you can't get the same base. So if you are unable to write both sides of the equation as powers of the same base, then write the equation so that one base raised to a power is equal to another base raised to a power. So if you're unable to do that, it doesn't matter what the bases are. So if you just have one base on one side and it's raised to a power equals another base on another side raised to a power, that's good. Doesn't matter what the bases are at this point, okay? Because you can't get the same bases. Next, take the natural log or ln of both sides of the equation and use the power property of logarithms to get the variables out of the exponents. Let me give you guys a second. Check to me. Okay. So, here's what we have. Use the power property of logarithms to get the variables out of the exponents. What we're doing is, like, what's the purpose of this? Again, the first case is, oh, I can get the same base on both sides, I can bring those exponents down, I can just solve it that way. This is useful in those cases, and I brought this up as well quite a bit. What if I have 2x, 2 to the x equals 9? I don't know how to rewrite 9 with a base of 2. I can't do that. That doesn't mean that it's not solvable, because if you could do trial and error and do 2 to the 3, 2 to the 3.1, 2 to the 3.12, you know, go through all those numbers and take forever, but you could find an exponent that eventually would give you 8.999 or 9.0001, you know, something really, really close. So you could get close. But that's, like, we don't want to do that, right? So how do we solve this? This one is already, like, that first part is already taken care of, where it's a base raised to a power equals another base. So we're good there. We don't have to move anything over. We're good. Next, take the natural log of both sides. So take the ln of both sides. Now, this is not multiplication. Ln by itself, just ln, that's not a number, okay? That is like a function. You are taking the natural log of a number. You have to. So it's not multiplying it by e. And that's what I get a lot of times on the test. Students are just like multiplying it by e on both sides, but that's not really what's happening. We're going to take the natural log of this side and the natural log of this side, because whatever we do to one side, we have to do the other. So I end up with the natural log of 2 to the x equals the natural log of 9. Now, you're probably thinking, like, why did we make that problem, like, way harder by introducing logs into it? Whatever you do to one side, as long as you do it to the other, you're keeping the equation balanced, right? The reason we want to use logarithms more than anything else is because x is in the exponent. So I can't just, like, bring the x down. I can't just take the square root of x. I can't, divide by x. I can't do any of that because x is in the exponent. So either you get the bases to be the same and you bring the exponents down, or you do this and it also allows you to bring the exponents down by using the property of logarithmic functions that says if you have a power, it can come down in front. You guys remember that from 7.4? If we have a power like x here, we can use the properties of logarithms and that power can just come down in front. And that's the whole purpose of it. The reason that we took the natural log of both sides was so that we could use that property to get the exponent out of the exponent, okay? Now I have x times the natural log of 2. How do I get x by itself? Divide by the ln of 2. So x equals the natural log of 9 over the natural log of 2. And now we have a way to solve problems that you can't get the same base. Now, again, how do you know the difference? Because both are going to be on your test. One says solve the following elementary. What does elementary mean? You can get the same base. The other ones like this are going to say solve the following exponential equation. Okay, so if it says the word elementary, do it the easy way, get the same base on both sides. If it just says solve the following exponential equation, you have to take the natural log of both sides. So let us look at an example.
On Hox for that x equals the natural log would be...
Oh yeah, sorry, I didn't go further. I don't have my phone, so I don't have my calculator. What is the natural log of 9 divided by the natural log of 2? Everybody get that? 3.17, okay, good. And also on Hox, it's gonna ask you to type in the exact answer and then the approximation. So it literally looks like this, where it has an x equals, and then like a big box where you'll type in natural log of 9 over natural log of 2, like literally type that in, and then it'll have a little approximation symbol, and then another box for you to put it in your calculator, okay? Okay, so here we have e to the 4x minus 5 equals 91. So again, right off the bat, I know, well, I can't raise e to a power and get 91. Not off the top of my head, I can't, okay? So, x is in the exponent. X is in the exponent, so I can't add, subtract, multiply, divide to get x out of the exponent. I need to get x out of the exponent so I can figure out what it is. In order to do that, I need to apply the property of logs. Can't apply the property of logs if there's no log. So I'm going to take the natural log of both sides. We have the natural log of e to the 4x minus 5 equals the natural log of 91. Why did we take the natural log of both sides? So that I could bring the exponent down. So I could bring it out front. So the whole reason for doing that was so that I could get that x out. So I end up with 4x minus 5 times the natural log of e equals the natural log of 91. Before we go further, what is the base on natural log?
E.
E. So e to what power? E to what power will give me e? 1. E to the first power is just going to give me e. So this is actually just 1. So 1 times anything is just itself, so it doesn't change it at all. So I can just write down 4x minus 5 equals the natural log of 91. What is my goal? Get x by itself. Same goal I've had forever. So add 5. Now this natural log of 91 just stays the natural log of 91. So I can't add the 5 into the 91 because, you know, I'm not taking the natural log of 5. So it's 4x equals natural log of 91 plus 5.
But you could, like, work out the natural log of 91 and add it.
Yes,
Okay.
but my suggestion is to wait till the end because again, it's going to want you to type this whole answer in the big box
Okay.
and then do the approximation. So divide by 4 because we're trying to get that x by itself. So x equals the natural log of 91 plus 5 over 4. So it's going to want you to type that big thing in the box. And then it's going to have a little approximation symbol for you to put it in your calculator. Now, if you put it in your calculator all at one time, please make sure that you put parentheses over the top and then divide by 4. Should get 2.38. Questions? Okay. Let us look at this one. Can you raise 7 to a power and get 767? No. And I don't want you to waste time there. Again, that's why I kept stressing, like if it says solve the following elementary, yes, you can. You absolutely can. But it just, if this one doesn't say solve the following elementary, it just says solve the following exponential. So immediately I need to go into doing the logs. Because what you're going to do is you're going to do like 7 to the second, 7 to the third, 7 to the fourth, and get frustrated and you're going to be like, I can't solve this, right? That's why I stress the word elementary. Elementary means, yes, I can. Exponential, if it just says exponential, it's either going to say elementary exponential or just exponential. If it just says exponential, immediately, logs, okay? Take the log of both sides, log of this side, log of this side. So we have the natural log of 7 to the negative 2x plus 9 equals the natural log of 767. Why did I take the log of both sides? So that I could get x out of the exponent. So I could get that x out of the exponent. So I could bring this down to the front. So negative 2x plus 9, natural log of 7, equals the natural log of 767. Okay, so I see where x is. This time natural log of 7 isn't so easily, like, I can't just get rid of it because it's not going to be 1. However, I see like this whole thing out in front and a natural log of 7, so a lot of you are inclined to distribute, so that's what I'm going to do, is just start out by distributing. So we have negative 2 natural log of 7x plus 9 natural log of 7 equals the natural log of 767. What is my goal? Same goal I've had forever and ever. Get x by itself. Here's the x. That's what I want to be by itself. So don't let the fact that there's all these natural logs like trip you up. You can just get x by itself like you normally do. We have this 9 natural log of 7 being added, so I'm going to subtract it over. Now we can't combine those natural logs, so it just stays natural log of 767 minus 9 natural log of 7. Again, this x is what I want to get by itself. It's all being multiplied by negative 2 natural log of 7. So what should I do? Divide by negative 2 natural log of 7. Divide by negative 2 natural log of 7. That natural log, this natural log of 7, this natural, they cannot cancel. Why? Because this natural log of 7 also goes into here, and if you cancel it, it doesn't work, okay? So this cannot cancel, it needs to go into both, so you just leave it like that. Now again, Hawks is going to want you to put that whole thing in the big box and then approximate it. And you should get 2.79. This is another place where it's really beneficial to practice with your calculator if you have to do it piece by piece. So if you struggle to put it all in at one time, if you are putting it in all at one time, make sure you put parentheses around both the top and the bottom. If you are struggling to get the right answer every time like that, then go ahead and just put in the natural log of 767 in your calculator. Write that number down. Write it down like 4 or 5 decimal places. Don't just round to 2 because you're rounding within a problem, and if you round within a problem, then your final answer is going to be super rounded, right? So write it down 4 or 5 decimal places. Then put this in your calculator, write it down 4 or 5 decimal places, put this in your calculator, write it down 4 or 5 decimal places, and do it that way if you're struggling. Okay, obviously I cannot get e raised to a power and get 109. But there's another problem here as well. The 2 is not the base, okay? The 2 is just being multiplied by the e. And whenever we first started these problems and I listed, you know, like here's what you do, you get a base raised to an exponent equals another base, and it can be raised to an exponent or not. That's not one singular base raised to an exponent. The 2 is not being raised to the exponent of 3x plus 11. So we need to get the base raised to the exponent by itself. 2 is being multiplied, so how do I move the 2 over? Yeah, I divide by 2, divide by 2. Now, a lot of times it's not going to end up being like super nice, like 54.5, which it does in this case. So I'm just going to leave it as 109 divided by 2. I'm going to leave it like that because, again, a lot of times it doesn't end up being a super nice number. And if you round here, then you're going to be rounding your answer off a little bit, okay? Okay, again, can't get the same base. So how do I get the x out of the exponent? Natural log of both sides. So I take the natural log here, take the natural log here. So I end up with the natural log of e to the 3x plus 11 equals the natural log of 109 divided by 2. Yep. So why, again, remind yourself why you did that, because a lot of times I'll get students to do this part right here and then they get stuck. They can't remember where to go, because it is intimidating. Like logs, natural logs, they are a little bit intimidating. You're introducing all these new letters and words. Why did you do this? You did it so that you could get x out of the exponent. Remind yourself of that. Why did I do that? To get x out of the exponent, to bring it down. So this will come down front. So 3x plus 11 equals times the natural log of e equals the natural log of 109 divided by 2. What is the natural log of e? 1. So I end up with 3x plus 11 equals the natural log of 109 divided by 2. I'm trying to get this x by itself. So what can I do?
Subtract 11.
Yeah, just like you normally would get any x by itself. 3x equals natural log of 109 divided by 2 minus 11. Divide by 3 to get that x by itself. You can't really do anything with that fraction on the inside of the natural log. It's just stuck as what it is. I cannot remember if Hawks also forces you to keep it as a fraction, meaning like if you tried to do 54.5, if you did the point, if it would say, oh, alert, whatever, you know how it does. So, you know, that would be kind of up to you at that point. But there's no way, like mathematically, to simplify this any further than what it is. So you would type this in the big box, then you would put this in your calculator, and you should get negative 2.33. If you don't have your calculator today, I highly suggest that you try to do these, because these are like, again, problems that are worth quite a bit, because there's a good chunk of information here that it can be tested on. You know, we have exponentials, we have logarithmic properties, knowing to bring that down, and then just solving an equation. So, you know, it's like 8 to 10 points for this one problem. So I want to make sure you can do it. Any questions about this? Okay, that is the end of algebra. Woo-hoo.